Today we'll be discussing about the switch debouncer. Okay. So this is an application of SR latch. Okay, I think all of you know what is a latch. What's a latch?
Sir used to hold the data.
Correct. It holds the value. Okay, or in common terms, if we say the data is held. Okay, so we have seen a lot of type of latches or flip flops, right? So RS, then JK, T, D, right? So we have seen a lot of flip-flops and latches. So one of the applications is a switch debouncer. So you should understand when I say a switch debouncer, generally when we use the switches, okay, there can be small spark internally. Okay, internally there is a small spark. I don't know how many of you have observed, right? So whenever you turn on or turn off, generally it will be when you turn on. Okay, you will see a small spark. Okay, so this can be avoided when we actually use a switch debouncer. So whenever there is a contact, okay, so instantaneously there is a voltage that is getting applied, and because of which you find a small spark. Fine. So let us look into it in detail today, and we'll try and understand as to how this switch debouncer works. So this is one of the application of SR latch. Okay, fine. So a common problem involving switches is the occurrence of contact bounce. So what is this contact bounce? Even though we have probably turned on, okay, so the contact may not remain in the same place, but then it might uh, get back to its different state. Say for example, I'm turning on a switch, it might turn off automatically. Okay, so that is because of contact, a concept called contact bounce. As in waveforms, with the center contact of the switch is in lower position, the voltage at terminal B is plus V volts. Okay, so we are actually referring to this diagram. So we have voltage V, okay, and this is the ground, and we have terminals A and B. So this can get connected either to B, okay, or this can get connected to A. Okay, so how is it going to get connected? Oh, just a moment. So here, okay, just like how this is connected here. So the same thing will be connected here on top. So uh, which means it can be either the voltage can pass through B or it can pass through A. So there are two contacts there. Okay, so there are two contacts. So that is what it's referring to. While the voltage at terminal A is 0 and vice versa. So wherever it is connected, okay, so here if it's connected, then whatever voltage is here, okay, that is present. And here it's not connected, so the potential is actually 0. So this V can be 5 volts, 10 volts, 12 volts, okay, whatever the value. This opening and closing effect due to the springness of the contacts may occur. So there is spring, right? So, so this contact can sometimes bounce. Okay, so it is just like once it connects here, okay, it will not immediately connect, but then it will slowly vibrate and then it will connect due to the spring effect. Okay, right. The switch remains in upper position. During contact bounce, the center contact does not return all the way to terminal B. So which means when I am trying to change the connection from B to A, so when it bounces back, it's not going to come and touch this terminal, right? It might come halfway and then again, connect to A, disconnect for some time, connect, disconnect slowly, and then finally connect. So this is the way in which the spring effect happens in a switch. So due to which what happens, suddenly there will be some spike in the voltage, right? So there can be an increase uh, in the potential, right? Okay. So now let us look into the waveforms and you will be able to understand the concept. Okay. So this occurs again when the switch is moved from upper to lower position. This effect of contact bounce is normally undesirable. So we do not need this kind of effect. If I want this contact to be connected here, just it should get connected. I do not want the spring effect. Okay, so that is what we are trying to say here. Okay, so the voltage across A. Okay, so either it is connected to A or it is connected to B, right? So when it is connected to B, okay, this is voltage across B and this is voltage across A. So when it is connected to B, of course, so this terminal is not connected, right? So when this terminal is not connected, it means it should be a low value. Okay, it should be having a low value. But for some reason, I am not able to annotate. Okay, kindly adjust. So, when the contact is connected here to the B terminal, okay, so I will have this voltage high, okay, high voltage. So this is V. So I have put it as general V. So this V, as I mentioned previously, it can be either 5 volts or 10 volts, whatever is the value. Okay, fine. And then when it connects to A, okay, see it is trying to connect to A. So when it has connected to A, there's a spike. Then it has come out of A because of the spring effect. So it is 0. Then again it got connected to A. It has come down and then now permanently it is connected to A. So before connecting to the A terminal, okay, there is a lot of spring effect happening. Okay, spring effect happening due to which it is not getting connected to this terminal one shot. Okay, there's a connect and a disconnect happening. So that is what you can see here in the waveform. So the connect and the disconnect, the connect and the disconnect, and then finally it connects back properly. The same effect can be seen here with respect to B also. So from A, when it is shifting to B, okay, suddenly it connects and then disconnects. And it connects and then disconnects. Okay. Then again it tries to connect. Right. So permanently the connection happens or it is shifted from A to B. Right. So this is how this bounce effect is happening. Now this effect can be nullified. Okay, this effect, this kind of spikes, we do not need this kind of spikes. Okay, either we want it to be completely off or we want it to be completely on. So this kind of effects can be actually nullified when we use a SR flip-flop. Okay, so in an SR latch or SR flip-flop, the values are held. Okay, so you can see that this waveform, okay, VA, VB, here also VA, VB are both same. But then the output that you get, right? The output that you get after these are passed through the SR latch is constant. So that is your Q and Q bar. Q is off, Q bar is on. Here it's on, off, off, on. Okay, so they are uh, opposite to each other, as we all know. So how is this happening? So the same circuit, Okay, the same circuit here. Instead of connecting it to B, okay, when it connects to B directly, instead what we are doing is we are using the help of SR. Okay, so through this, okay, through this, all the small values, okay, when it gets connected, the small values that are there will actually be grounded. Okay, and only the higher value will be passed through. Okay, so say, it gets connected for small amount of time. So here it is getting connected for small amount of time. So when it gets connected for small amount of time, that can be nullified because of this resistor here, right? So what happens when it is nullified because of this resistor? We do not find this kind of effects. Okay, so only the values which are little higher will pass through and it will enter R. The similar thing happens here also. Okay, the smaller values are all nullified with the help of the resistor, and then it passes through S. Okay, so in this fashion we can actually nullify these effects, and we can find a proper value which is Q and Q bar. Okay, so let us just have a look at it. Okay, um, in the theory that I have written, a very simple but important application of SR flip-flop, okay, or SR latch, is to eliminate the effect of contact bounce. So this is what is our point of interest. We do not want these spikes happening, right? We do not want the ups and downs. We do not want ones and zeros happening instantaneously. We just want either one to be constant, or we want zero to be constant for some amount of time. We do not want both the values, happening at the same time. Okay, instantaneously. So positive voltage plus volts corresponds to logic 1, which is high value, and the ground is corresponding to low value, which is logic 0. By the use of two pull down resistors, logic 0 values are ensured at the S and R terminals of SR latch whenever the center contact of the switch is not connected to either terminals A or B. That is when the switch is open. So another thing that you can think of is, whenever this is open, okay, whenever this is open, it is as good as this getting connected to the ground, right? Now see, one of the terminal is connected here, right? So which means A is left open. So since, excuse me, since A is left open, so these values are grounded with the help of resistor. Whatever values might be here, so those values are all grounded. So which means it will not allow for spikes to happen, these kind of on off spikes to happen, because as soon as the value comes through, it will get grounded. Okay, so whenever the switch is open, hence by the use of SR latch, the effect of contact bounce is eliminated. So a simple application, okay, just connecting an SR latch and probably a resistor. Of course, you will have to design the resistor based on the formula. Okay, so you will have to do a little bit of, you know, um, P is equal to IR. Okay, you will have to use that formula, and using that formula, you will have to find out how much of resistance that you will have to put in here, so that it suffices our purpose. Okay, so in this way, whenever there is a small value or whenever it is not connected, the values are grounded. Okay, so in this way I can eliminate these small spikes. Okay, and I can just keep it on or off. Okay, so now you can imagine here the values. Okay, now we all know the values of SR flip flop. So when S is 0, so S is corresponding to values of A, R is corresponding to values of B, right? So when S is 0, okay, and R is 1, we should have a value 0, right? Similarly, when I have 0 here, and this will be considered as 1, okay, so this whole thing. So 1 and 0 will actually give me 1, okay. Similarly, 0 and 1 should give me 0. So in this way, I will have a proper waveform. And of course, Q bar becomes the opposite of Q. Whenever this is 0, it becomes 1. So the main thing that you have to understand here is whenever it is not connected, okay, let's say this terminal is not connected now. It is grounded. All the values are grounded with the help of resistor. So I will not have these kind of spikes. So 1 will be considered. Okay, the highest value will be considered because the pulse width is high, right? Similarly here, when it is connected with B, these pulses are nullified. I will just consider this whole thing to be 1. So this happens with the help of SR, because when I give S is equal to 1, my value should be 1, right? So if you can see, okay, when S is 0, then your output is 0. When S is 1, the output is 1. And Q bar, of course, it's going to be opposite, 1, 1. We are not going to take that case because that's going to be into a toggle state or invalid state. And 0, 0 will actually give us what is in the memory. What value was there, the same thing will retain in the memory. So I hope all of you have understood the application of switch debouncer, right? Any doubts here?
No, sir.
Okay, fine. So just with an application of this latch, we were able to make values constant, because either it can be a 0 or it can be a 1. So S can be either a 0 or this can be a R can be a 1. So we are not actually getting into both the 1 state. So which means that invalid state is not going to occur here, right? Because we have just one contact. So one contact cannot be connecting to both the contacts at the same time, E and B terminals, right? So we will never experience the invalid state. Okay, 1 1. 0 0 also might happen if in case I don't give any voltage here, right? So that time here also B will not have any voltage and A also will not have any potential. In that case, whatever was in the memory, okay, so Q and Q bar, the same thing will be retained. Once I start the potential, then it's either going to be S is equal to 0 or 1, R is going to be 0 or 1. So this 0 and 1 is actually corresponding to the high and low values accordingly. Okay. So in our upcoming lecture, okay, we will probably revisit the carry look ahead adder, and we'll try and understand the equations involved and the applications. Okay. And if any doubts, you can feel free to post your questions.
So where is the switch debouncer used? Like its application?
Application, that's what, see, I told you, no? Maybe in your uh, pulse generators, you want to generate pulse. Okay. So in that case, you can even use this in your labs. Okay. You have this analog signal generators, right? Analog signal generators, then digital signal generators especially, right? So when you want to generate these kind of pulses, okay, so in that case, internally it will actually have a SR latch. Have you all used a pulse generator?
No, sir.
Yes, you will be actually
No,
seeing,
sir.
seeing that in your labs. Okay, so you will have an analog signal generator and digital signal generator. So I need to have signals to be constant, right? I do not want signals to go on and off. So in that case, I will be using this switch debouncer. Okay. Yes. Any doubts? Any other doubts? Please feel free to ask. So there are, still a lot of other applications. For example, in lighting, you want the light to go on and off, right? The blinking mode. So that can also be done with the help of this SR latch. Okay, the blinking LEDs, for example. So even that will have a small circuit which actually takes the voltage, turns off, turns on. You can even think of the fan, okay, where you want to give a constant potential to it, so that the regulator. You can think of the regulator also, where you need to give a constant supply, and it turns in a specific speed, the motor, right? You can even think of water pumps, wherein it needs to have a constant voltage. So applications are plenty. Okay, so you can think of many applications wherein you want constant voltage. Yes, have I answered your question?
Yes, sir.
Okay, any other questions, students? Okay, fine then. So we will catch up in the next class. Okay, as I discussed, we'll be looking into the carry look ahead adders. Okay.